These examples, we're solving literal equations, and typically that involves taking a formula or something that has mostly variables in it, but solving it for a different variable. So in this example, we start with I equals PRT, interest equals principal times rate times time. It's solved for I, but we want it to be solved for T. So what we want to do is get everything that's not T on the other side of the equation. So we divide both sides by PR. So T is equal to I over PR. Time is equal to interest divided by principal times rate. In example B, we have another formula that involves money and principal. This one is A equals P times 1 plus RT. We want to solve this for P, so we need to get rid of everything not P. In this case, it's pretty simple. We're just going to divide both sides by 1 plus RT, and so P equals A divided by 1 plus RT. Here we have a different example. It's not all variables, but there's definitely more than one variable. We're asked to solve for x, and what we should notice is that there's an x on the left-hand side of the equation, and there's an x over here on the right-hand side of the equation. We want to get x all by itself. That's how we know that we've solved it. However, this x on the left-hand side, it's inside some parentheses. So we're going to need to distribute the 3 so that we can undo the parentheses. So that's one of the first things we're going to do. So we distribute the 3. Now we're ready to get all the x's on one side and all the not x's on the other side. That involves adding the 15a and subtracting the 4b. Notice we can't combine these 3 different terms. They're not like terms, but they still go on the same side because they're not x's. We still don't have x all by itself, so we need to divide by 2, and we end up with the fraction 15a minus 4b minus 2 all over 2. Just because this 2 can divide by this 2 does not mean we should. Leave your answer like this unless each of the 3 terms are divisible by 2. Here's another example. We're solving for x again, and like before, I have an x on the left-hand side and an x on the right-hand side, and this x is inside some parentheses. So we're going to start off the way we did before. We want to get rid of the parentheses, get all the x's on one side, and get all the not x's on the other side. Now what you notice here is, unlike the 6x and the 4x that we had in the previous example, you cannot combine these two. That's the best you can do. So you need to think of a way to be able to write the letter x only once. And what I mean by that is when you factor an x out, you've got the letter there one time, the letter x. Now it's relatively simple to get x all by itself. Divide both sides by b minus a. Now if you notice, that looks a little weird. So if we factor a -1 out of the numerator and a -1 out of the denominator, we get an equivalent response or result of a over a minus b. Either of these answers is acceptable. Here's example E. We're solving for x again. We've got x in 2 different places. So get rid of the fraction by multiplying both sides by a plus 3. Now that involves distributing here x times a, x times 3, -3 times a, -3 times 3. And now you notice we've got 3 terms with x in it. We need to get all 3 of those terms on the same side. Like the previous example, I have 2 terms with x in it that I can't really combine. So I factor the x out, then I divide both sides by the not x parts. And what I have here looks a little odd because it's got all of these negatives. So I factor a -1 out, I factor a -1 out. Notice these cancel. So my final result looks a little nicer if I leave it as 3a plus 9